Hello everyone, in this tutorial we are going to provide a solution to this interesting question in 3 different ways. I'm going to show you how JSS students should solve this problem. I'm talking about grade 7 to grade 9, and how SS students should solve the same problem, talking about grade 10 to grade 12, and also college and university students. Therefore, we are going to explore 3 different methods. I created this problem in AI Teacher. You can also do the same. I'm going to drop the link in either the description box or the comment box below. Let's get started. The question reads, if x minus 3 to the power of 2 is a factor of x cubed plus ax plus b, then we are asked to find this a and b. So if you are in JSS class, I know you are familiar with long division. So we are going to do long division. Because this is the mother function, right? It is the mother function. So this is a factor of this. So we expect if you take this, you divide by this, the remainder should be what? 0. Just like if you take 6, you divide by 3, this is going to give you 2 without remainder. So the remainder is 0. Therefore, if you divide this by this, you shall expect a remainder of 0. All right. So let's expand this. What is the expansion of this? If you take x minus 3, you raise it to the power of 2. This is equal to the first term squared, right? X squared minus, because of this minus, 2 times x times 3 is what? 6x. Then negative 3 squared, that will give us what? 9. So this is what we are going to use as what? Divisor. So we are going to do something like this. Then what should be inside? This. But we are going to write it as a full polynomial. So we have x to the power of 3. X to the power of 2 is missing, but please include it. 0x squared. It is missing, right? Then x to the power of 1 is there, which is ax. Then the constant b is also available. So we're going to start. How many lots of x squared can be found in x cubed? Only x. It's just like taking x cubed divided by x squared. That will give us just x. Write your x here. Then take this x, multiply by all of these 3 times and write them here. X times x squared will give us x to the power of 3. X times negative 6x will give us what? Negative 6x squared. X times 9 is what? 9x. 9x. Draw a line and subtract. We are subtracting. This minus this is 0. 0 minus 6x squared. Minus will make this plus. So this is going to give us what? 6x squared. Then ax minus 9x. So let me even put that in bracket. Ax minus 9x. Then b minus nothing is b. You repeat the same process. X squared can divide 6x squared exactly 6 times. Right? It's just like taking 6x squared divided by x squared. That will give us 6. Then take this 6, multiply by all of this. So 6 times x squared will give us what? 6x squared plus. No, this should be minus, right? Because of this minus sign. Minus. 6 times negative 6x will give us negative 36x. Then 6 times 9 will give us what? 54 plus 54. And we are going to subtract. This minus this is 0. So this minus this is going to become positive. So we have, what do we call it? 9. Or should I do it directly? Let me do it directly. Let me drop ax. Then minus 9x minus, this is plus, that is minus 9x plus what? 36x, which is positive 27x. Positive 27x. I can even factor out x. I think that should be better, right? A plus 27, outside we have x. So it's just like factoring x out, just to minimize our work. So we should have x outside, all the same, please. Then lastly, we have b minus 54. b minus 54. So remember what I told you. This is the remainder after dividing this by this. This is the quotient and this is the remainder. I told you that the remainder must be 0. If at all, this is a factor of that. So this implies that a plus 27x then plus b minus 54 must be equal to 0. And under which condition will this be equal to 0? For all values of x, it implies that this and this must be 0. So a plus 27 must be 0, and also this one. But let me finish solving this one. As you take 27 to the other side, it is going to become negative 27. So this is the value of a. Then the other one, b minus 54 is equal to 0. It implies that b must be what? As this crosses over, it becomes positive 54. And these are the two values of we are looking for. For a, it's negative 27. For b is 54. And why do we even have this and this to be 0? Irrespective of whatever the value of x is, this cannot be 0 except if this and this are 0, because 0 times whatever is 0 plus 0 is 0, right? So this is for JSS students. Now let us go to the higher class and show you how they should solve the same problem. If this is a factor of this, then it means that this has 3 factors, because this is a repeated factor, right? X minus 3 times x minus 3. We should have another factor, x plus something, which together will give us this. So I'm going to introduce that factor. It implies that if we introduce another factor, maybe x plus k is a constant number, then we multiply by this x minus 3 to the power of 2, then this will automatically give us x to the power of 3 plus ax plus b. That is what we have to do. We already seen the expansion of this. Let me bring it down. X plus k multiplied by x squared minus 6x plus 9, right? This is the expansion of this, and this remain x to the power of 3 plus ax plus b. Now let us expand. This is by relating the coefficients. If you are familiar with partial fractions, you should know what I mean here. So x times x squared will give us x to the power of 3, right? X times this will give us negative 6x squared. X times 9 will give us what? 9x. Then you come to the second term, which is k. K times x squared will give us what? Kx squared. K times this will give us negative 6kx. K times 9 will give us 9k. So let us collect the like terms just with x squared together. I have one here and I have other one here. So we have x to the power of 3 plus. You're going to add their coefficients and factor out the x squared. The coefficient here is what? Negative 6. The coefficient here is k. Then all of them sharing x squared. Then thus with x, we have one here and we have the other one here. You also add their coefficients. We have 9 here and we have minus 6k. All of them sharing x. Then we have the constant. That term without x is just 9k. Remember, this is equivalent to this. So we are going to relate their coefficients. X cubed and x cubed, they are the same, so we don't have to worry ourselves. What is the coefficient of x squared here? It's minus 6 plus k, but we don't have any term with x squared, which implies that minus 6 plus k must be equal to 0. So minus 6 or k minus 6 all the same equal to 0, which implies that k is equal to 6. Though k equal to 6 is not what we are looking for. Let's move on. The coefficient of x is 9 minus 6k. 9 minus 6k is the coefficient of x here. The coefficient of x here is a. This is equal to a. But we have seen that k is 6. So this is what? 9 minus 6 times 6. 9 minus 6 multiplied by 6 equal to a. Oh, sorry, this is 9. A. 6 times 6 is 36. And 9 minus 36 is minus 27, which means that a is equal to minus 27. Remember this value? Yeah, the same thing as the previous one. Then the constants. The constant here is 9k. And what is the constant here? Just b. But we know that k is 6. Therefore, b is equal to 9 times 6, which is what? 54. Yeah, we got the same solutions. A is minus 27 and B is 54. Now let me show you how college students should solve the same problem. If you are a calculus student, there is something you should know about this function graphically. Because the leading coefficient is positive, you know how the shape of cubic function looks like, right? It looks like this on the graph. So I'm going to do the same thing. We have learned that this is a factor. If this is a factor, this must be a repeated factor. Yes. It means what? If you are to solve this problem, you take x minus 3 to the power of 2 equal to 0, which means that x minus 3 is equal to 0 and x is equal to, what do we call it? Positive 3. But twice. Remember, we have two factors here, x minus 3 times x minus 3. So the curve is going to touch positive 3 and takes a turn. Unlike maybe you may see a function like this. You see, maybe if this is 3. But in this situation where we have 3 twice, it is going to touch the point and takes a turn. So if you have a value of 3 here, this curve will be somehow like this. It is just going to touch that point and takes a turn. So there are two things you should know about this. At this point where x is equal to 3, y must be equal to 0. So it means that f of 3 must be equal to 0. Then this is a turning point. We have two turning points. And the derivative at that turning point must be equal to 0. So therefore, f prime of 3 must be 0 as well. So these are the two functions or equations we need to solve this problem. So let me wipe this. So let's start with this one, f of 3. Plug in 3 here. F of 3 is equal to, wherever we have x, we replace it with 3. So we have 3 to the power of 3 plus a multiplied by 3, then plus b. This must be equal to 0. Yes, because we have it here. This is 27 plus 3a, then what do we call it? Plus b equals 0. Should we make b the subject? But let me find f prime of x first. It means we should differentiate the function. Differentiate this, you have 3x squared, because the power will drop down to multiply, and x to the power of 3 minus 1, which is 2. Then the derivative of ax is just e. Then f prime of 3, it means what? 3 multiplied by 3 squared plus a. This must be equal to 0 from here. 3 squared is 9, And 9 times 3 is 27. So we have 27 plus a equals 0. And if you take 27 to the other side, it becomes negative directly. So a is equal to negative 27. We have just obtained the value of a. You can take this value back here and solve for what? B. So we have 27 here plus 3 times a. 3 multiplied by negative 27, right? Negative 27 plus b. This is equal to 0. This is 27 minus 3, 1. Is this 8, 1? Right. Plus b. This is equal to 0. 27 minus 81 is negative 54 plus b equal to 0. If you take this one to the other side, it becomes positive. Then b is equal to positive 54. In all of these three methods, we got the same solutions. A is minus 27 and b is positive 54. Thank you for watching. Do share, tell, and colleagues. Bye-bye.